We all know that all internet companies have servers. I want you to think about something. How does your computer know where these servers are? From the respective IP address. How does it communicate with them when they live across the world? Moreover, if a website launches today, a few moments later we can access it. How does our phone somehow end up being able to communicate with something that didn't exist a few moments before? I am Arya Bagheri, and today I'll explain how computers communicate with each other over the internet. While this process is standard and happens automatically, knowing how different protocols work enables you to understand various cyber attacks and mitigation techniques better. You can't clearly understand SYNFLOD, SYNACFLOD, or any other type of DDoS if you don't understand IP spoofing. To understand IP spoofing, you need to understand the Internet Protocol, which is the topic of this video. As a bonus, in the end, I will briefly go over the different vulnerabilities of this protocol. Some of these attacks still don't have a reliable defense strategy, so keep watching. Returning to our original question, how does the data your computer transmits end up at the right place? Let's say YouTube servers. There clearly exists a connection. That's how information is shared. But you don't have a wire for every website on the planet going through your computer. That would be dumb. So how do your requests find their way through billions of internet devices, sometimes around the globe, to the target? And how does the target send responses back? The Internet Protocol, or the IP, helps direct network packets to the server. In simple terms, you use the Internet Protocol whenever you visit a website, upload something, or watch some videos. Every internet-enabled device usually has one or two IP addresses. Your personal computer usually has a public and a private IP address. Now, in some cases, like some servers, a computer might have multiple IP addresses, but the general principle stays the same. The most famous type of IP is IPv4. That is what's running most of the web now. We are slowly moving towards IPv6 though, which is a good thing. IPv4 addresses consist of 4 numbers that are connected by 3 dots. The public IP address is assigned to your router by your internet service provider. Now your router, through a process called NAT, makes sure you can connect to the internet without interfering with anyone else's connection. In this video, I will talk about the Internet Protocol. I will make a separate video about IPv4, its types, how it is structured, and how we can make it work faster, and link it down in the description. To understand how Internet Protocol works, let's think about the post service, since it is much more tangible than random bits of data dancing through a cable. The process, however, is roughly the same. So after you're done writing your love letter, you put it inside an envelope. Then on the envelope, you write your address as the sender and your target's address as the receiver. Then hand it to the post office, and this envelope magically reaches your crush. Similarly, on IP packets, you write the sender and receiver IP addresses and put everything you want inside of it. This way, the internet knows where to deliver the packet. If you wrote a novel that will not fit inside an envelope, you should divide it into multiple envelopes, then put a number on each so they can be put back together at the destination. In networking, This is called IP packet fragmentation, which we will get into later. So, Internet Protocol helps divide the data into multiple packets, then puts the sender and receiver addresses on these packets and sends them to the target. The target then reassembles these packets and processes the request. I will go over all the famous internet protocols, more than 30 types of denial of service attacks, phishing attacks, spyware, keyloggers, and ransomware. We will be having malware analysis, attack labs, and so on. So much content is coming. So definitely subscribe because I know you don't want to miss all that cybersecurity goodness. Now it's time to get into what you really came here for. How can attackers use the weaknesses in this protocol to attack a website? I will briefly describe each attack and not get into too much detail since they deserve their own videos. I will later show you how to perform them on a dummy computer and defend against them on various platforms and servers. Now it's time for my favorite part, vulnerabilities. Since the Internet Protocol is not regulated, authenticated, or authorized, IP packets can easily be spoofed. It is worth noting that authentication and authorization may concern the content inside the IP packet. The IP packet itself will always be see-through. This is exactly like a box in the mail. Anyone can see where it is going and the insides, but if you open the box and there is a safe inside of it, that's a different story. That's how your bank account info stays safe. They use the Internet Protocol to convey everything. Still, they heavily encrypt the data inside of the IP packet. So not the headers where the data is going is not encrypted. All the headers that we will talk about later, they are unencrypted, everybody can see them, no problem. The internet equivalent of the safe inside a box would be protocols like TCP/IP, IPsec, HTTPS, and SSL. They all encrypt the data inside the IP, but the headers, they stay completely transparent because if the headers are encrypted, then how should the routers along the way know where to deliver the packet? So all of the protocols that we just talked about, they all use Internet Protocol or IP underneath. Due to the bare Internet Protocol's vulnerable nature, DDoS attacks are practically encouraged, since on the server's end, there is no way of knowing if the source IP address has been tampered with. Tracking down the attacker and stopping the attack from happening is practically impossible. The only defense strategy companies use is to make their servers so powerful that they can withstand long-lasting, large-scale DDoS. For smaller parties, services like Cloudflare DDoS protection make it much more difficult to suffer from large-scale cyber attacks. You should know that more brilliant types of DDoS, like RDoS, some forms of the slow low-risk attack can still manage to damage your servers, even if you're using Cloudflare protection. So, along with using DDoS protection services, you should also take the time to study the Internet protocols, configure your firewall correctly, and secure your code. Man-in-the-middle attacks are also super common and can't be easily prevented. So they rely on this vulnerable nature of the Internet Protocol to learn whatever the user communicates with the website, even usernames and passwords. So this is it for this video. I hope you enjoyed it. Our next video will be about the IPv4 packets, how they're structured, and so on. That video should make it easier to understand how these packets end up at the right place. A fun fact before we part ways. Did you know that the subscribe button uses the same Internet Protocol that we just talked about? Give it a gentle push or click, whatever you're into, and see if it works. It's worth it. Stay paranoid and stay alive.